Class, Mrs. Calvi here. Quick tutorial on finding the area of rectangles and parallelograms. This will be 8.3 in your textbook. I have two examples here on the left side. Here I have an example for finding the area of rectangles. And I have my formula listed here. The formula for area of rectangles is A is equal to L times W, L standing for length, W standing for width. And if you can see, I have a rectangle here that happens to be 13 meters in length and 8 meters in width. So all I'm doing is plugging those numbers into my formula, and I am solving for my area. So in this case, my area is going to be equal to my length of 13 times my width of 8. All I would then do is multiply 13 times 8, and that would give me 104. Now, my unit here is meters, and what you have to remember, anytime you are calculating area, whether it's of rectangles, circles, parallelograms, area is always squared. So your unit has to have the square symbol. It's an exponent of 2. Now, for assignments in Google Classroom or assignments in GoFormative, you're not going to actually be able to put the exponent of 2. So you would be able to write it this way. If you can't do an exponent, you would just say 104 square meters. All right, and that's the same thing. So that's pretty basic. Area is equal to the length times the width. You multiply and you have your area of rectangles. Now here in this example, we are talking about area of parallelograms. And the formula for an area of a parallelogram is the base times the height. The base is going to be basically the bottom of the parallelogram. So if we look at my example that I have here, the base of my parallelogram is 2 1/3 inches. And the height, if you notice, what they did was they're finding the height of the parallelogram, and they have this dotted line with the little 90-degree angle square located here. So the base of this parallelogram is 2 1/3 inches, and the height is 3 1/2 inches. All right. Again, all I'm going to be doing is multiplying those two together. So let's go ahead and do that. So my area is going to equal my base, which is 2 1/3, and I'm multiplying that by 3 1/2. So here I have two mixed numbers that I am multiplying together. So in the past, if we have mixed numbers and we need to multiply, the first thing we would do is change those into improper fractions. So if you remember how we do this, we're taking the denominator, multiplying it by the whole number, adding in my numerator. So in this case, I would get 3 times 2 is 6. 6 plus 1 is 7. And my denominator stays as is over 3. So in this case, this would become, I'm going to go up over here. Whoops. Not sure what happened there. Okay, so my area is equal to, that became 7/3. And now I'm going to do the same thing for this improper fraction. Take my base, or my denominator rather, multiply it by my whole number. 2 times 3 is 6, and then 6 plus 1 is, again, 7, but this is going to be over 2. My denominator stays at 2. So I'm going to multiply this by 7 over 2. Okay, now if you remember, to multiply fractions, we multiply the numerators across and multiply the denominators across. So when we do that, we end up getting 7 times 7 is equal to 49. 3 times 2 is equal to 6. Now, I would not want to keep my answer as an improper fraction. I would want to go ahead and make that into a mixed number. And if you remember how to do this, this really is saying 49, our fraction bar means division, so divided by 6. So 49 divided by 6. So if I were to do that, Numerator always goes inside your division box, don't forget. So 6 does not go into 4. It goes into 49 how many times without going over? That would be 8. 8 times 6 gives us 48. We will be left with 1. So my final answer is 8 1/6. So the area of this parallelogram is, so the area is 8 1/6. Our unit is inches, and don't forget, area is always squared. So the area of this parallelogram is 8 1/6 inches squared. Okay, until I see you next time. Bye, guys.